Continuing then, Walker cell, normal conditions, rising branch of the Walker cell in the west, sinking branch of the Walker cell. Walker cell actually is global. So theoretically, this should be referred to as the Pacific Walker cell, but in general, when we say Walker cell, we always think about El Nino, we always think about the Pacific, so you can just say Walker cell. So what is El Nino Southern Oscillation? Here we are to the big story, right? Its name comes from the Spaniards. El Nino is a Spanish word. Southern Oscillation comes from our good friend Sir Gilbert Walker. It got combined into this name ENSO, which is more scientifically accurate, but it's not so exciting as El Nino anymore. Nonetheless, the Walker cell, which is the east-west cell in the Pacific, gets disrupted once in a few years. Nobody can explain you exactly why it happens, but once it begins to happen, there are a lot of processes that we can see evolving, and they have a life cycle, and there are ways to predict it, as we will see later on, which is important because, as I said before, El Nino affects weather and climate everywhere: droughts, floods, forest fires, fisheries losses, diseases, etc. So predicting it is very important, because if you can predict El Nino, then maybe you can predict its impacts ahead of time, and you can protect yourself, correct? Yes. So high pressure in the eastern Pacific weakens. Exactly why we don't always know. So the trade winds also become weaker. The warm pool then is not held against New Guinea and Indonesia anymore by the trade winds pushing the water west. So it begins to kind of slosh back towards the east. The thermocline that is shallow in the normal conditions in the east begins to deepen. Why? Because remember, trade winds are pushing the water west, diverging and creating upwelling and bringing the thermocline up. If the trade winds weaken, then the divergence weakens, the upwelling weakens, and the thermocline relaxes, or it begins to get deeper in the eastern Pacific. So anomalously speaking, it's a downwelling. The trade winds never completely disappear. They become weaker. So that means the downwelling is a deviation from the normal condition. So the upwelling will be weaker. So if you compare to normal conditions, you can think of it as anomalous downwelling. You have to get used to these things in your head, but just remember, oftentimes we talk about anomalies because it's like having a fever. Your normal condition is not having a fever. When you have a fever, the temperature goes up, so that's an anomalous condition, right? And if you reduce upwelling, you're going to reduce the cold water that's coming up, the nutrients that are coming up, and you're going to reduce the primary production, which means the biological production goes down as well. So especially the Peruvian anchoveta industry, which is so big for so long, begins to suffer. So if you have predictions of El Nino, maybe the fishermen can plan better. Well, there are lots of details on how the forecasts are actually used by the fishermen versus the banks that give them loans versus the government that gives them help, or even a woman at home who is managing the finances, or a husband who has to bring the income. So the socio-economics of forecasts is very complicated, but in general, forecasting is a good thing, right? Okay, so we will look at the animation of going from normal conditions to El Nino conditions later on, but look at this figure and compare it to the normal conditions we saw before, where the thermocline was shallower in the east, was deeper in the west, and the warm water was pushed up against the western boundary of Australia, Indonesia, and Philippines, and so on, and New Guinea. And here, the thermocline has gotten more flatter. The east-west slope of the thermocline has become flatter. The east-west temperature gradient has become flatter, which means the pressure gradient is also flatter, hence the winds will be weaker, right? So this is the first example you are seeing where you are actually getting into complete ocean atmosphere interactions. Okay? For whatever reason, let's say trade winds got weaker, that would make the upwelling weaker, that would make the sea surface temperatures anomalously warmer, that would reduce the pressure in the east, anomalously strong, higher pressure, that would reduce the east-west pressure gradient, that would reduce the winds further, which would reduce the upwelling further, which would make the sea surface temperatures warmer further, reduce the pressure further and pressure gradient and so on. So you are in this loop, and the loop can start anywhere. Maybe something from the west pushes the water eastward, and that begins to reduce the pressure gradient and the winds, and the cycle starts. Or maybe something reduces the trade winds and so on. So this cycle of ocean atmosphere feedbacks between winds, the thermocline, the sea surface temperatures, the precipitation and warm temperatures on the west was first discovered in 1969 by Jakob Bjerknes. Hence now it is called Bjerknes feedback. Okay. So where did the name El Nino come from then? It turns out that these warm temperatures that we see here off the coast of Chile and Peru actually are the warmest in December, January, February. Spaniards are all nice, good Catholics. What's important for them in December? Christmas. So this cold water, even though it's productive, it's not good for swimming, for example, and it brings very dry weather and deserts on the coasts. Actually got anomalously warm around Christmas time. So they decided this was a little gift from Jesus. So they called it the little Jesus, or the Christ child, El Nino. Nino means boy. El Nino means the boy, the Christ child, right? So El Nino occurs around Christmas time, brings anomalous cold, warm water to a coast that is very cold. So it was considered a little gift. That's where the name El Nino comes from. Where does southern oscillation come from? I'll come back to that in the next podcast, because this is already pretty long. I want you to digest these concepts. Okay? So normal conditions, weakening trade winds, reduced upwelling, warming in the east, increasing sea level pressure, reducing the east-west pressure gradient, further weakening the winds, further weakening the upwelling, further warming the sea surface temperatures. So this positive feedback between the ocean and the atmosphere creates El Nino. Okay? So just try to remember the sequence of things. Even though we don't understand exactly what starts and where it starts, once it starts, we can often look at it, and the numerical models, the weather models, the climate models are now pretty good at predicting it many, many months in advance, and we will see why that could be useful. Okay? El Nino. Haven't defined southern oscillation yet, but you know what El Nino is now.